Select, upcoming, activate. I got flagged. Yeah, they did flag me for that. They got mad at me. They said I was promoting hate speech. I'm like, it's self-hate speech. Like what? Like what? It's not hate speech. 1 hour flight is 1 day of jet lag. Yeah, and I was on 14 hours of flight, so I guess I have 2 weeks of jet lag to get over. It's a mess. You low-key want to get good at graphs? Cool. Well, go check out Stooky's stream on sorry, I had it somewhere. Sorry, on Friday. It's at noon my time Pacific. But if you go to this website again, actualofficehours.com, click on the streaming schedule, and you can go see all the cool streams that people are doing. Go check it out. Yeah, I got flagged for calling myself the R word for not being able to do things, and they flagged me for hate speech. I'm like, okay. Whatever. Let's see. Looks like we got 2 questions in the queue so far. So let's go spin. We got oh, Mr. Silver. Dude, who is Mr. Silver, by the way? Who's Mr. Silver? Disqualified. Your question yesterday with the candy canes and stuff. No, it was TikTok, Sam. Yeah. No, Twitch is pretty tame. TikTok like analyzes live what I say. Like they look at my transcript. Mr. Silver definitely has 67 involved. Well, Mr. Silver gave us a heater of a question yesterday. It took us like 30 minutes to come up with the wrong answer.
You're not that guy, pal. Trust me. You're not that guy.
And then it took another like 20 minutes and Narosky writing up like a whole page to do a double proof by contradiction or something. Mr. Silver X. Oh man, I don't know if I keep wanting these Mr. Silver questions are tricky. Okay, whatever. Let's go choose a winner. See who we got, and let's go gambling.
Let's go gambling!
Well, it's your lucky day, Rusticles. You did have a 46.6% chance because you submitted first.
I did.
Solve the differential equation. Oh wow.
Oh, dang it.
Do you like that I added that, Zach? Zach, I added this just for you.
Oh, dang it.
I did the thing. Yes, thank you for the suggestion. It was pretty fun. Okay, let's try to figure this out. Sorry. Yo, what does this D mean? Sorry. Is this
that's the derivative operator. So this is technically fractional order differential equation.
Sorry, what? Wait, what? Are we doing an imaginary derivative?
Yes.
What's an imaginary derivative?
So the start of it was in fractional calculus. They basically said, well, how would we define a half derivative? Right.
Okay.
And then it expanded from there to be able to do like imaginary order, fractional order, and all of that. So you can take like a pi order derivative or a root 2 order derivative.
Okay.
An imaginary order derivative, which is what we're doing here.
D to the 1/2 is defined. So even Zach is like putting his hands up. He's like, "Why would you do this, dude? Why would you do this?"
Because I gave you an easy question yesterday.
I know. I do need a hard question today. Okay. All right. Walk me through this then, I guess. Because I've never seen a fractional derivative, let alone an imaginary derivative.
Your first step would be to apply the Fourier transform. Because what's nice about taking the Fourier transform of something complex is it comes out as I omega to the I alpha multiplied by your little y hat of omega.
Okay. So yeah, let me again. I'm pretty sure I know what a Fourier transform is at this point. I think it's like f of omega is equal to, I want to say it's 2 pi integral from -infinity to infinity e to the negative I omega t f of t dt. How close am I?
Yeah, except I don't think there's a 2 pi.
There's no 2 pi? Really?
Yeah, I think that's included in the omega.
Oh, this is if we do it in frequency space. Okay, sorry. If it was f of like
Yeah.
frequency, then it would be that. Okay. Question: is there a point where higher level math just becomes practically useless and pointless?
Shit, not good.
Thanks, Jeff. WStream. Jay, to answer your question, practically useless and pointless, it depends what level of practicality you're doing, right? If all you have to do is, I don't know, like weigh out food because you're a chef, then, I mean, pretty much you don't need any math past algebra. But if your job is to be, let's say, for instance, an aerospace engineer, you probably need to know at least some sort of like sense of differential equations in order to do like fluid analysis and stuff. And then if your job is to be a quantum gravity researcher, like if you want to like study like crazy things in the cosmos, then you need even higher levels of math. You need like set theory and, I don't know, like discrete and all sorts of crazy maths, which it's kind of like a choose your adventure, Jay. It depends what you want to do in life. And sometimes challenging yourself by doing math that's like above your level or like harder than what you're used to can inspire you to maybe go into fields that you wouldn't have thought of because you're like, oh wow, I'm actually kind of good at this shit. Or it's also like going to the gym. It just makes you better at doing easy stuff. You know, the amount of times I need to bench 315 in real life is like none.
Disqualified.
I never need to do that. But if I can do it, it means when I need to push something that's, let's say, like 180 pounds, it's really easy for me. So that's kind of why. Okay. Yeah, math is a tool for other sciences. Totally can happen. And then someone said, do you think anyone can learn math? Yes. I feel so dumb in college right now. Don't worry. I felt I can't use the word, but I felt really stupid in college too.
Bruh.
That's a totally normal part of life. I think, don't worry. You're not the only one. Not everyone, nobody has their shit together. If there's any evidence in what's going on in the world. So just keep trying. And then, yeah, if you need help with questions, TikTok's blowing up today. Wow. They probably unbanned me from things. Go check out the website down below, actualofficehours.com. If you go submit a screenshot here, this is the website. Type in some sort of username I can recognize you by. Drop a screenshot in, hit upload. It will then get put into our queue. So then this is the queue of questions currently. And then what we do is we randomly pick questions to go over. So we're on the first question, which is from Breasticles. And all right, so let's dive into this a little bit. Again, if you're watching this and you're in middle school and high school and this is really scary to you, do not worry. Yeah, don't let this like scare you. This is just some really high level math that Breasticles loves to challenge himself and me with. This is kind of like a math workout. And if you don't understand any of it, it's totally cool. We do all sorts of math questions down from like middle school up through, I'd say this is like graduate college. But
Yeah, it's probably something. I just came up with this.
it's probably something.
Yeah.
Okay. All right. Okay. So this is correct for a Fourier transform, correct? Yeah.
Yes. Yeah. But we
Okay.
technically won't need that, like,
We technically won't need this.
right now. So what we would do is when we apply that Fourier transform to
Uh-huh.
our original equation, and for simplicity's sake, just to make it look prettier, I said let lambda be equal to that coefficient on the right, the gamma plus I beta.
Oh, okay.
I
You're just
said
gonna call
let's-
this
let's
gamma.
make that equal to,
Okay, that's fine. Okay,
or,
so,
yeah,
let's
lambda.
Let gamma plus I beta equal lambda. Okay, sure. So now we have
Yeah, just put
d to the I alpha
easier.
y of x is equal to gamma y of x. Okay, I'm
Yes.
cool with this.
So when we go ahead, we're gonna apply our Fourier transform, and that d of I alpha y of x
Yeah.
is just gonna become I omega to the I alpha of y hat of omega.
Okay, one sec. I need to like. First of all, Radish, what's up, bro? don't say hi too many times. I gotta put like a timer on this. One sec. One sec. Man, why am I making this so difficult? Edit. There we go. Customization, flow mode, 10. Cool. There we go. Okay, that's fixed. Okay. All right. So I'm gonna apply a Fourier transform onto, I'm assuming f of t, and is this, am I applying it to the whole thing or just to y of x? I'm curious.
You're just applying the Fourier transform to the entire
thing. Okay.
the entire thing, and just from the linearity of the Fourier transform, it just applies to each one.
Okay, so let's do it. So I'm gonna do e to the negative I omega t, and then we're gonna say of this, right?
Kind of. So technically, we don't have to do all of that.
Okay, we don't have to do all that.
I forget exactly like.
There's some hand waving involved here. We're just like, yeah, it's okay.
There's a like a specific identity with Fourier transforms. Let me send a screenshot of what the actual identity is.
Yeah, send it to me. I want to see. I want to learn.
I
mean, I can write things down,
easier.
but I like to understand them.
Yes. So it is.
And then tell me where you're posting them. There you go. Perfect.
I just sent it in chat
Gotcha.
right there.
Awesome. Yeah, that's right. Chat there is amazing. Okay, so let's see. Okay. Assume alpha is real and the imaginary derivative is defined by its Fourier multiplier, where what does this f here mean? What's this? It's like function.
Yeah, that's the Fourier transform.
Oh, sorry. Okay, the Fourier okay, so this is the Fourier transform. Okay, so doing the Fourier transform on a imaginary derivative thing of a function y of omega is equal to I omega to the I alpha y hat omega. What is y hat?
Yeah, and your y hat is just your y of x times e to the I alpha.
Oh, okay.
It's the integral of it. So it's basically what you had already written for the Fourier transform.
Yeah. And then this is dx, I assume, right?
Yeah.
Or is it d alpha?
Dx.
Dx. Okay, cool. All right. Okay. So I'm gonna do that to this, and I guess what we're gonna get is this in? No, this doesn't depend on x, so I don't care. Okay, so this is to the I alpha,
and you can just leave it in terms of that y hat.
Sure.
Because at this point, it's something that we could just solve for algebraically.
Okay. And then this is still equal to gamma y of x. Oh, sorry.
No integral on the y hat though.
Oh, no integral.
Yeah, it's
Oh, I see. I see. Y hat is equal to the integral. Y hat's equal to the integral. Got you. Okay. I see. Okay, gamma y of x. Okay.
We also apply the Fourier transform to the right side as well.
We also play the Fourier transform to...
Yeah, so that becomes y hat as well.
Uh-huh. Oh, yeah. I see.
No,
so when you say... because... So the Fourier transform, like, acts on the derivative part, and then it also acts on the function part, and when it acts on the function part, you just get a y hat of x, and there's no dx here anymore.
Yeah, it's just like a multiplier. It's just I don't actually entirely know where it comes from, but it's just kind of a identity.
It just is what it is.
When you apply it, when you apply it to that derivative operator.
Okay, cool. All right, so we got to here. I'm cool with this. Do I just divide by y hat of x?
You would subtract.
I would subtract. Okay, got you. All right.
Yeah. So if you subtract the full lambda y hat of x and then factor it out.
Good. Okay. This is like happy algebra. I'm happy with the algebra if we just like wave our hands enough at the other stuff. What does Fourier do? Fourier is really cool, man. It does a lot of things. For the practical sake of like experiments and things, it's a way to represent a time series as a superposition of a bunch of sine waves, or sine and cosine waves, I guess. I think it's just sine waves because they just have phase shifts.
There's a sine and there's a cosine Fourier series.
Right, yeah. So it's a way, like, let's say, for instance, you had some data that looked like some crazy whatever the stuff. You could imagine this as, I don't know, like a constant, well, this wouldn't look the same, whatever. You imagine it as a constant wave like this with one frequency on top of, I don't know, let's say like another wave that somehow just does that. But it's about putting a bunch of waves on top of each other to describe a time series. And then from that, you can start doing some fun filtering things. So say, for instance, you have a time series, and when I mean time series, it's like you took some data, and let's say your data looks like all like stupid messy and stuff like this, right? A Fourier transform allows you to identify within that messy data, which is a bunch of waves acting at the same time. You can pick out, for instance, like certain frequencies of waves. You can be like, oh, cool, well, this one's doing this. And then I also have, I don't know, something on top that's maybe doing this. And you can like filter them out. There's some cool stuff. Mathematically, I think it's just like, it's sometimes easier to evaluate integrals in what they call like frequency space, I guess, or K space, omega space. I don't know. It's just different names for things. And it's similar to a Laplace transform where it makes the calculus and the algebra nicer to work with. And solving, PDEs. I never took PDEs, so, but I imagine it would also be useful for, stuff like that, solving partial differential equations. Yeah. Sounds really useful. Yeah, it's really powerful. Yeah. Yeah, if you want to learn more about Laplace transforms, which I think are also stupid powerful, make sure to go to Zach's streams on, I think Wednesdays is when he's doing like his differential equations. Or his like Laplace transform stuff. And also he's getting ready for a big math talk that he's going to talk about Laplace transforms and like how to teach them. So
it's technically also a Laplace transform right here.
Is this a Laplace transform? Okay.
Yeah, the Fourier transform is just a special case.
A special case of the Laplace transform?
Yeah, it's where it's purely imaginary.
Oh, that's cool. All right, so this is all equal to 0. I agree with that. Cool. Mm-hmm. So then that means I have two solutions, right? Either this equals 0 or this equals 0.
And so here's where it kind of gets into the weeds.
Because we're not in the weeds already. Like what?
Yeah. So we know that if our y hat is equal to 0,
yes,
that our y of x is also equal to 0, and that's trivial. So,
that's trivial. Yeah, we don't need that. Right. Yeah,
so that means that our I omega to the I alpha has to be equal to our lambda.
Okay.
And so we can go through solving that, and then it gets a little bit more into the weeds.
Let's go.
Because
I mean, this isn't too much of the weeds. I mean, I can understand if this is an integral and it's going from negative infinity to infinity. This is never going to cancel itself out. So I understand why this would need to be 0.
Well, it also it kind of gets more into the weeds because later, after we figure out our solution to the right term, we would end up defining our y hat of omega as a delta function.
Like a Dirac delta function?
Yeah, just off of like, sort of inspection.
Okay.
Because once we solve for the I omega to the I alpha is equal to lambda, we're going to get a bunch of frequencies.
Are we going to have to reverse transform back?
Yeah. And so once we solve this and figure out like our frequencies, then we basically look at it via analysis and say that it's a delta function because it vanishes everywhere outside of these specific frequencies where I omega to the I alpha minus lambda is equal to 0. And then so we would call it a delta function and then do the reverse transform of the delta function.
I'm super curious, like while we work on this, I'm just gonna give this to ChatGPT. I just want to see it like choke on it.
The problem with it when I ran into it is it kind of gets to a correct answer, but it basically just like throws in like, we know these eigenfunctions. It's got to be a e to the function, but it doesn't really work that way because the complex logarithm is multi-valued, so we need to add up a bunch of different values with the summation.
Okay. All right, so what do we do from here?
Okay, so we would go ahead and just solve that for lambda by taking the log of I omega.
So you want me to leave this as lambda? Oh, sorry, are we solving for gamma or lambda?
We're solving for omega.
Oh, omega. What am I even? All these Greeks, dude.
Yeah, think of it as we're saying like a function m of omega, which is what we're solving for now, times the y hat of omega. So we're finding our specific values of omega, or our frequencies, where this term is equal to 0. And those frequencies are going to be the only terms where y hat of omega is going to be allowed to blow up and still satisfy our equation.
I'm going to take the ln of both sides then, right? So I have ln of I omega times I
would be
alpha.
The log.
I can't just... Why can't I do ln?
Because it's a complex log.
It's a What the hell's a complex log?
It's basically for the complex values, it's multi-valued for the logarithm, so we have to redefine it as the ln of r plus the argument.
Wait. He says Zach's messing with me. He's like capital LN. Okay, fine. All right, I'm just gonna write log. Okay, so we're at that, and then I gotta move the other thing over, right? So that I get log. I don't know, what is this? Log I guess, right? Plus log omega. These are log rules. I remember these. Equals log lambda over I alpha. Is this equal to 1? Is this because is it log base I?
No, not exactly. So I go ahead and back up. Instead of doing the log of it raised to the I alpha, just do the log of I omega.
Oh wait. Sorry, what? Just do the log.
So this
of
is
I
when this is when complex analysis comes really helpful.
Where did this thing go?
We know
where did I alpha go?
We know. We're not worrying about that right now.
We're just not going to worry about it.
We can just multiply that in later.
You know, e to the 2I pi equals 1. Yes. Naroski's like, what are we even doing anymore?
You're not that guy, pal. Trust me. You're not that guy.
It's okay. We're going through the weeds. We're gonna figure it out. Yeah. Dude, I am worried though if even Naroski is like, yo, what the fuck is this? Let's keep going. I love it. All right. So I'm gonna leave this as just log of I omega, right? Is equal to log lambda. We cool with that?
Get rid of the log lambda as well.
Get rid of the log lambda as well. Okay.
Yeah, so we're gonna start by just evaluating what log of I omega would be, just as a complex logarithm.
Oh, just as a thing. Okay, cool. We're learning about complex logs.
Yeah, so we define that log or that log to be the natural log of the absolute value of omega.
Okay, natural log of the absolute value of I omega.
Just omega.
All right, so just omega. Okay.
Plus
I
pi over 2 times SGN of omega.
Right. Yeah, I think I can write like this. Sine is either +1 or -1, right? Based on the sine of omega.
Mm-hmm.
Yeah. For those that haven't seen this before, this is 1 if positive, and it's -1 if negative. Cool.
All right, and then from here, if we were to just like exponentiate it, we can, and then add the I alpha back in, we could say that I omega to the I alpha equals
Am I going to do
e to the I alpha.
So this, so wait, this was a log base e.
Yeah, it's complex logs are a bit different because since they're multi-valued, we can't just say natural log and throw in a value. We say it's called the complex log, and then we define that complex log using the argument.
Got it.
And the,
okay.
Yeah.
So I'm gonna do but then we're gonna put the I alpha back, I guess, right?
Yeah, we can just throw the I alpha back in.
Okay, cool. All right. So then this is gonna be I omega, right? Or I omega to the I alpha.
So yeah.
Is equal to e to the ln. So that's just going to be absolute value omega, right? Times e to the pi I over 2 sine omega. Yeah.
Let me check.
That look kind of correct. I think it does. Yes, Dante, I can definitely help you with the calculus problem.
Not quite.
Okay. Dante, go to the website.
No, I left the ln up in the exponential because it works out a bit easier later.
Oh, okay.
But because we're considering or multiplying in the I alpha, it becomes e to the I alpha natural log of the absolute value of omega minus that SGN term.
Okay. Oh, I see.
Yeah, because
you're raising it to the I alpha, so you're multiplying everything by I alpha.
Yeah.
Okay, fine. So then I have I omega to the I alpha is equal to e to the I alpha ln omega, and then we're gonna say, but then I times I is -1, so I'm gonna say minus pi over 2 SGN omega. Does that kind of look okay?
With an alpha on that term as well.
With an alpha on that term as well. Yeah. Gotcha.
Yeah, because we're doing by I alpha.
Okay. Don't worry, Narosky. I've never seen a complex logarithm either. This is new territory.
And then we would say we're going to call lambda a function rho e to the I theta.
Wait, we're defining another lambda?
No, it's the same lambda.
Okay.
It's the same lambda as before, but
because we said this
plane.
we said this thing was lambda.
Yeah, that is lambda.
Yeah. Okay.
We're gonna solve for it as rho e to the I theta since we're still working in the complex plane.
So lambda equals rho e to the I theta. Cool.
All right, and then now we have two cases. Our case where our frequency is positive and our case where our frequency is negative.
Right, omega positive and omega negative.
About the omega greater than 0, we would go ahead and
leave this as a minus sign, right?
Yes.
Okay.
We would say that I omega to the I alpha is all of that with the negative in there. So
okay.
E to the negative alpha pi over 2.
I omega to the I alpha is equal to e to the I alpha ln omega minus alpha omega alpha pi over 2.
Alpha pi over 2. Yes, that's correct.
And then the other case is just a plus sign, right?
Yeah. And then just from inspection, we can say that rho is, in essence, yeah. Because we said that our lambda is rho e to the I theta, we can just look at our values and we know.
So is rho just equal to 1 then? No?
Or rho would be equal to e to the negative
to the alpha
pi over 2.
I see that. Okay. Yeah, because I see. Because e to the a minus b, for those that are watching, just a little simpler. This is the same thing as e to the a, e to the minus b. And we're going to say that, like, this part here is rho. Yeah. Okay. So I'm going to say rho is equal to e to the negative alpha pi over 2. Yeah? Okay. That's for this case, though, right? Rho changes for this one, no?
Yeah,
is it-
yeah, row would be different for that one. And then but it would bring up an X or a negative. So then we're gonna figure out our alpha, ln, absolute value of omega, which is just theta plus 2 pi n, where n is an integer.
Okay. Okay, that's that. And then theta is equal to alpha ln omega. Yeah. We agree with that?
Theta is...
Or yeah, right. Because if it's rho e to the I theta, this is the theta part.
Yeah. But let's say 2 pi n.
Plus 2 pi n. Okay. Yes, because it repeats itself. Okay. Sure.
And then, so when we substitute all that in, we get that our omega for the positive value of n is the exponential of theta plus 2 pi n over alpha.
Okay. E to the 2 pi n. Oh, I see. Okay. You're going to move this over. And then you're going to divide by alpha. Okay, so then you're going to say...
Yeah, because technically it's theta plus
Got
2
you.
pi n, but it doesn't really matter since n can take any integer value, whether it's positive or negative is kind of arbitrary.
Okay. You're going to do theta minus 2 pi n all over alpha is equal to the ln of omega. You're going to do e to the... I'm going to get e to the theta minus 2 pi n all over alpha, yeah?
Yeah, and that's our... omega value, and then technically it's omega positive sub n because our omega varies based off what our n value is.
And then omega n is just going to have a different sign here.
Yeah. Well, not up in there in the X.
No. Yeah, actually, omega will be the same. Sorry, it's rho that'll change. Yeah. Yeah.
No, our omega changes based off what we choose n to be.
Really? But I feel like this part's the same, right? The only difference is this.
Well, so we're selecting different frequencies. So our omega n isn't like our functions. These are omega n is the points where our y hat can blow up, right? Because these are points where that whole right hand side, the I omega to the I alpha minus lambda, that's when it's equal to 0. And because that's equal to 0 at those points, that's when our y hat omega can take any value and blow up, which is why we would later define it as a delta function, because other than these specific points, it's 0.
Gotcha. Okay. Dun, dun, dun. Okay. What do we, maybe let's like work for a couple more minutes on that, and then I'll just be like, this is a cool exercise.
Yeah,
because otherwise I think I'm losing the audience at this point. They're just like, what the fuck is this?
Huh? Yeah, that's understandable. So we could just follow similar steps for case 2, just to save time. It's just the negative exponent, so you just bring a negative in front of the e.
Okay.
But it's the same theta plus 2 pi n over alpha.
Plus 2 pi n. Got you.
Yeah, they can be plus or minus.
It doesn't matter, right? Because n can be whatever. Got you. Okay.
And then now we get into what I was talking about earlier. So we would define our y hat of omega to be a delta function because it's 0 everywhere except for these specific points. And then so our solution would become the sum.
Is it omega minus omega plus
of delta? Yep. And then technically I think there's a coefficient a of n out there, but I don't think it really matters that much.
Okay.
And then similarly, we're going to add our sum of all of our delta functions for the negative values.
Okay. So then we'll do this. I can like kind of follow along what's going on, but yeah, I definitely need like a lot of hand holding here.
Yeah, it took me a lot of hand holding too.
Is this in this book? This is the book that you have?
No, I was just like, what could I make that's difficult? And I was like,
oh, you're like, what could I make that's just like absolutely challenging?
I wonder how I could solve a complex ordered differential
Oh, this is cool. Okay, and this
then
is
I
what
went
like
down the
Wolfram
rabbit
does.
hole.
Yeah.
Yeah, well, Wolfram and GPT. I couldn't get it to work in Wolfram, but Wolfram has a GPT.
Got you. I see. And yeah, AI is going to kind of say the same thing, right?
Yeah.
Y of x can
Yeah,
either be 0 or the other thing has to be 1. Uh-huh. Okay. And so then what? Are we done?
Almost. So we know that the inverse, when we go back to our normal time space, or just from like Fourier pairs, like if you look at the tables where they have like the back and forth transforms, our y of x just becomes some exponentials. So you would get the sum of n of e to the I of our omega positive times x, and then the same thing but for our negative.
Okay.
The x would be up in the exponential as well.
Got you. This is discrete, right? This is a discrete Fourier transform at this point.
No, it's technically not discrete, because we're not doing a summation like as part of the Fourier transform.
Got you.
It's because our logarithm was multi-valued, so for each value that we could pick of that logarithm, we'll get a different frequency. Now we could take a look at it and say, let's worry about what's called the principal branch, which is basically like just saying the normal logarithm, and let's just not worry about all this other stuff. But what we're considering is just the Nareski sent something.
Dude, y'all are speaking a different language here, dude. I love it, dude. It's cool. It's cool to see like all the different types of math. My opinion after learning from Mr. Beast, Mr. Breast. Oh, I saw Mr. Beast first. I'm like, what is Mr. Beast doing this? Because maybe maybe Naroski knows about transforms. Oh, okay.
I think he does.
Cool.
Maybe. I'm not sure if he knows it. But yeah,
I
so
see.
those summations are just like when we consider the general solution to a differential equation, it's every solution.
Yeah.
Like when you solve a non-homogeneous one, you take the homogeneous solution and then that extra solution and sum them.
Cool. Okay. So are we done? Is this good?
Yeah, pretty much.
Nice.
And then you could just substitute in your lambdas, but it just makes it a show of exponentials to exponentials.
Cool. I learned about some new things. Even with something that's like super confusing and I've never seen before, I always appreciate being exposed to new things. I think it's a very valuable thing in life. Yeah, clap, clap, clap. IKEA's like, oh, great question. I solved it a while ago. You did not, IKEA. No, I appreciate it. Honestly, like, Brescos, this is cool that you just like go out of your way to just like go like, hey man, this isn't like solved. This isn't in a textbook. You're just like, oh, what would happen if I did this?
Yeah, I couldn't really find anything on it anywhere. That's why I kind of had to crutch ChatGPT and then hope that the process was correct. And
you sure you don't want to be a math major, dog? Correct. I feel like you should be a math major.
I am a math major.
Oh, I thought you were engineering.
No, I'm a double major in computer science and math with a minor in physics.
Okay. There we go.
So
with the minor in physics.
Like all of it, yeah.
Oh, beautiful. What happens when you show your professor this? I'm just curious. Have you tried
I didn't
showing
show him none of this.
What would happen if... Why don't you show it to him?
I just don't.
Oh, okay. I think it'd be cool.
Like
I would just say, like, myself as a professor, if like a student came to me with something like this and it was, you know, in my wheelhouse and challenged me, I would be much more apt to writing you like a really nice letter of recommendation, because I'd be like, oh, this person like is genuinely interested in this outside of school. Just, you know, help yourself out.
Yeah, it is. Now, granted, in fairness, though, I have a tendency to forget to turn in homework, so they probably would look at me and be like, so you got time to solve all this?
Oh, no.
Not do your homework.
Yeah, we need a course correct. Yeah, it's okay. It's okay. That is the number one thing they'll come after you though is for not turning in homework, because they'll be like, talent is great, but laziness is like.
Well, my argument is that I'd rather spend like an hour and a half, 2 hours solving something like this that challenges me and gives me something new and like gives me a better understanding than like
busy work.
Doing an hour and a half of repeatedly just solving different like
I know
integrals or derivatives all over again.
Yeah, you're definitely not the typical student for sure. It's all good. All right, cool. Fun question. All right, let's see. Pratosh says, could you teach integration and differentiation? Wow, I mean, that's like 2 whole semesters of calculus. I don't know if I could do that in an hour and 52 minutes. Pratosh, if you have a question about integration or differentiation, I'd be more than happy to go through it here. So again, yeah, if you submitted a question to our queue here, these are the current questions in the standings. If you want your question to get selected first, if you want to like boost your chances, you can always click this upvote button here every 3 minutes and it'll give you extra votes. Bomb your teacher?
You're
Don't
not
do
that
that.
guy, pal. Trust me.
no.
You're not that guy.
I don't condone that. Okay, all right, let's go choose a winner. Let's see what we're gonna get next.
Let's go gambling!
Gladiator, it's you.
Good job!
Beautiful Gladiator. Oh, nice, cool. This looks like calculus. Minimization, love this. Let's do this all day. All right, 2 towns, Ancaster and Dundas, are 4 kilometers and 6 kilometers from an old railroad line that has been made into a bike trail. Okay. Points C and D on the trail are the closest points to the 2 towns, respectively. The points are 8 kilometers apart. Where should a rest stop be built to minimize the length of trail that must be built from both? Okay, very cool. Actually, this is a very fun question, actually. Okay. All right, so you have the railroad line here, and then you have Ancaster, and then you have Dundas. And then, so, oh man, I hate that they also used C and D here. That's unfortunate. Okay. We're gonna say like Ank and Dundas. Call Dundas B? Yeah, let's just do that. Yeah, okay. Dundas is now Boondas. Just because I said so. Yeah, because like, what? Why? Okay. And then it says, okay, so this is the old railroad line, right? And then they say, points C and D are the closest points to the 2 towns, respectively. Okay, so here's a cute little thing about geometry. If you want to know how to get from here to here in the shortest amount of distance, okay, so let's pretend pretend you're in town A and you want to get to this railroad line. The shortest distance happens when you are perpendicular to the line you're trying to travel to, right? So if you look here, right, you can also think of the extremes, right? If the angle's not perpendicular, if it's like way over here, this is a huge amount of distance.
You're not that guy, pal. Trust me. You're not that guy.
We don't want that. That sucks, you know? But and then here's also longer. So the minimum distance occurs when you're 90 degrees, right? And then this is going to be point C. And then we can say the same thing here for the point D, which is the closest point to the trail. That's also going to be 90 degrees. Great. Awesome. And then, all right. And then this is 4 kilometers long. This is 6 kilometers long. And then C and D. The points are 8. Wait, okay, here's my question. Which points are they talking about? The points? What points? Point C and D, maybe? I'm going to assume they mean that. Assume they mean that this distance is 8. Yeah, right? Where should a rest stop be built to minimize the length of trail that must be built from both towns to the rest stop? Where should a rest stop be to minimize the length of... Wait. Wait, is the rest stop on the trail? Know that A and B could be on the same side of the track. That's true. That's true as well. I want to draw triangles. Call me Pythagoras. Yeah, triangles are dope.
That's dope.
Okay, I'm just confused about the question. Where's the rest stop? Is the rest stop just somewhere like over here? Is it just somewhere randomly? Like what? I assume the rest stop would be... Oh, I see. This is not built yet. Uh-huh. I got it. All right, I see what we're doing. Yeah, let's draw some triangles. I agree with that. Let's do that. The trick is actually a civil engineering problem, not calc, and the correct answer is wherever the most inconvenient for the flow of traffic. Or it could be a... Okay. I think I understand what we're doing. So this is what's happening, right? Yeah, I guess so. Okay. And then... Where should a rest stop be built to minimize the length of trail that must be built from both towns? Yeah. Minimize the length of trail that must be built from... Is the rest stop where the two connect? I think I kind of understand this. Yeah, okay. All right, well, we can start labeling triangles all day, sure, right? Yeah. If this is 8 and then this is 6, then I know this is 10. I guess I'm just trying to understand like what the question's asking. Do we want to build like a new trail so that like someone like does this and like ignores these things? You guys with the questions today. I thought the two hypotenuses meet at a rest stop. Okay, so you could say that. I think I kind of understand what you're saying. You're saying A and B are not on different sides of the railroad track. Let's do this. You're okay. It's okay, dude. It's okay, Endeavor. Okay, this is gonna be like boondoss. And we'll say that this is this, right? Is it where they intersect? Yeah, I mean, I'm still confused at what the question is even asking. Like, what's the point of the... Am I trying to just connect A to B? If I want to connect A to B, I just build a fucking trail this way. Like, why do I care about this? Why do they have to both get to the bike trail? Where should a rest stop be built to... Well, yeah, I don't know what the fucking question's asking.
I think you would use your trig to figure out the
intersection
length of the hypotenuse, and then add the two hypotenuses together, and then minimize that. Because I think the rest stop has to be on the trail.
Okay. You're saying that the rest stop has to be somewhere here?
Yeah, I think it's got to be on the trail. I'm not sure.
Where should a rest stop to minimize the length of trail that must be built from both towns to the rest stop? Oh, okay. I think I see what you're saying.
Yeah, so then
You're
I
saying
think
that
the trail
some-
to the hypotenuse.
Something's got to be from here. Like that, maybe? Kind of like this?
I think so.
Okay. And then this
And
is
then
the amount of
those are
trail
right
that needs to be
triangles.
built. Got you.
Yeah, and you could use
I
the
see.
Pythagorean theorem.
So actually, I
add
don't
them
really care about
together,
this thing,
and then
right?
figure out what minimizes
Yeah. Okay.
the total.
Super weirdly worded question. But, okay, so we're trying to figure out where we need to place this thing such that the total amount of trail distance that needs to be drawn is the least. You can kind of think of some extreme cases. Let's say, for instance, that the rest stop was placed here, right?
Do you mind me trying to help?
What's up?
Do you mind me trying to help?
Oh, I would love for you to help. Yeah. What's up?
Yeah, because I'm too tired to keep sending pictures of
You're okay.
geometry.
What's up?
So, if we let R be the rest point on the
Yeah.
line CD, right?
Yeah.
Denote CR as X, then
Yep.
RD is gonna be 8 minus X.
I agree with that. Yeah. And then RD is equal to 8 minus X, right?
Yeah.
Yeah.
Then reflect point A along the line CD.
Reflect it along the line CD. So you mean like over here?
Yeah.
Okay, sure. Okay, we'll call this like A prime.
So if you can you copy the line you drew, like the line AC? Can you copy it and paste it? Yeah.
Yep.
Okay. Now, if A prime is the reflection of A,
Yeah.
along line CD, then AR plus RB
Yes.
is going to be equal to A prime R plus RB.
Ooh. This is actually really clever. Okay. So yeah, okay. This plus this, which is what we're trying to minimize, right? So we're trying to minimize AR plus RB. I agree with that. But then you were like, oh, well, wait a minute. If we reflect this across, then this distance is the same as this distance. Okay.
Yeah,
cool.
and this happens because the line CD becomes a
Perpendicular bisector.
perpendicular bisector.
Yeah, exactly. Okay, cool. Okay, so now we're trying to minimize A prime R plus RB. Yeah.
Yeah, and I'm sure you can see that it's minimized when they are collinear.
Correct. Yes, because if
Yes, and this is because the sum A prime R plus RB is always greater or equal to A prime B.
Yes. Yeah, exactly. Right. Yeah. So just visually so I can show people. Yeah. If let's say for instance it was shifted off center, right? Like kilter. Then this would be it. Right? And this distance is obviously longer than this distance. It's kind of like stretching out a bow. And then also
exactly.
Yeah. Oh, that's very cool, actually. Right. Okay. So straight line is the shortest path in boring old 2 dimensions. Yep. Okay. Yeah. So this is cool. This is cool geometry argument. Okay. I was gonna brute force this with Pythagorean theorem and then just do like try to use calculus, but you don't need to. Right. Yeah. Shortest distance is when A prime R is collinear with A prime B. Okay.
Yeah.
Okay, cool. And so,
no, it's just a matter of similar triangles now.
right, yeah, okay. So this distance is 4. And then this is, let me think about similar triangles. Similar triangles means that I need the ratios to be the same, yeah?
Yeah.
So I need the ratio of this to equal the ratio of this to this.
Exactly.
Cool, okay. Gladiator, do you understand that, Gladiator? It's kind of a cool point Narosky's making. Narosky's saying that if these are collinear, right, then this triangle will be similar to this triangle. Because, and you can think of a couple options here, right? Because they're both going to have a 90-degree angle, and also the same angle here, which means they also must have the same angle here. Yeah, this is very cool. This is very, Narosky, thank you. Very cool. Okay, so the blue triangles must be similar. Exactly. I was also going to set up a Pythagorean and take a derivative. That is the hamburger, freedom, cheese lover, American way of doing things. But our friends over in Europe have like more elegant solutions to things, which I think is really cool. It's fucking awesome. All right, blue triangles are similar. You're 3D printing a one-to-one double of me? Oh man, send it over when you got it, dude. I need more me's. Okay, blue triangles are similar. Okay, so by that, and we know that this is equal to x, and then this is 8 minus x. Oh, this is super cool, man. So 4 over x is similar to 6 over 8 minus x. Let's just solve. That's 32 minus 4x is equal to 6x. 32 is equal to 10x. X is equal to 3.2. Yeah?
Yep.
Nice. I think it's really cool. Fuck, that's dope. That's so cool. Gladiator's like, I don't know if my teacher will allow a non-calculus solution. No, dude, you should show this. Impress your teacher. I would be impressed. Yeah.
Yeah,
also,
I'm always like I've had a few people come to me like personally because I've started teaching a few people, and it's the biggest joy when you make a problem and you think, oh, this is gonna be difficult, right? And then somebody just comes and throws a solution that's 3 lines long that you haven't even thought about in your face.
Yeah. It's like the ultimate math flex. You're like just dunking on them. It's just like, oh, you wanted to do it the hard way? Here's the easy way.
Yeah, and it's always appreciated in my opinion.
Yeah. He says the answer is 4.8. Yeah. Well, 4.8 away from point D, I guess. X is 3.2.
Yeah.
Yeah. Very cool. So you can try doing it, Gladiator, if you want to. You can try doing the Pythagorean theorem thingy. I guess you'd have to solve for this and this, and then you're trying to minimize that by varying this. So just real quick, what I think that would be.
Yeah, I'm sure that's possible.
It is possible, yeah. Whatever. You could call this A, you could call this B. So A would be equal to the square root of 16 plus x squared. B would equal to the square root of 6 plus 8 minus x, 36. Square root of 8 minus x squared. And then you're trying to minimize that. So you can say like y is equal to a plus b. It's equal to square root of 16 plus x squared plus square root of 36 plus 8 minus x squared. And then minimize. Totally possible. It's minimize. Sorry, minimize. Too many M's. Good luck with your physics exam, video game wizard. Yeah. So the problem is like, dude, and Narosky is right. This is such a nice, beautiful, simple solution. This is uggo, dude.
You're not that guy, pal.
Oh,
Trust me.
no.
You're not that guy.
I don't want to like take that derivative and then solve it for 0. Oh, that's just gross. It's really gross. No.
Oh, dang it.
Okay. I like this. This is really cool. But I'll also put this in here if you want to try it. You can go try to do it if you want to do the calculus. You should get the same answer. Cool. right, let's see. Let's go do another question. And yeah, Narosky, anytime you want to just like hop in.
You don't have to write stuff up all the time. You can always just be like, hey man, like, let me just guide you through it real quick. You're totally more than welcome to do that. Yes, thanks Narosky for the elegant solution.
Yeah, no problem.
Gonna impress my teacher. Yeah, definitely gonna impress the teacher. Alright, let's go see. Who's the next question gonna be?
Let's go gambling!
It's Laplace. Almost Dante. It was almost you. Laplace won with an 8.9% chance. Oh, okay. More physics. I love physics. Send diapers to Dr. Gold? Why do I need diapers? Poison, dude, what?
Surprise, motherfucker.
Why? Why do I need diapers? I probably needed diapers for the first question, honestly. I was shitting my pants the whole time. I was like, wait, what's going on here?
It wasn't that scary.
It wasn't that scary. I think it more felt like I don't know, like I was just lost in the sauce, and I was like, oh, okay.
Yeah, that's how I felt when I was solving it.
I agree. But being comfortable being lost in the sauce is a very valuable thing in life. Very valuable. I think a lot of kids like shut down. The second they get lost in the sauce, they're like, nope. No. I'm done. I'm out.
Just gotta keep going.
Peace. Okay, let's see. Parallel plate capacitor has square plates of L separated by distance that is connected to a battery of EMF 12 volts until fully charged, and then disconnected while still connected to the battery. Derive the capacitance from first principles. First, starting with E is sigma over epsilon naught between the plates. Do not simply just quote this. Why not? Why can't I, dude? What? Excuse me?
Boring.
Boring.
No.
Okay. Okay, well, I know C is equal to Q over V, right? We know that. And then I think what they probably want us to do is to find... that's one way to define capacitance. Yeah, capacitance is equal to the charge over the voltage. That's one way to do it. But you can also do it using Gauss's law, because I think what we're gonna do here is we're gonna figure out the potential from the electric field. Right? We're gonna figure it out from this because we know that potential. Let's see if I remember this correctly. No, electric field. Yes, no, electric field is equal to potential over distance. I think that's correct. I think E is V over D.
Yeah, or you could use the Laplace equation to solve the Laplace.
What? No, stop.
No.
It's actually like really easy in this case. You just integrate twice.
Oh. I think we just need to use this. Okay. Okay, so in this case, potential is equal to E times D, right? And then they gave us what the electric field is between the plates. The electric field is sigma over epsilon naught. So times D, so that's equal to V. And then they want the charge. Oh, interesting. Okay. I think what we have to say is that charge is equal to sigma A, because this is charge density. And then this is area. Okay, so I think eventually what you get is that V is equal to, well, okay, sorry. Let's step back, sorry. C is equal to sigma A over sigma D over epsilon naught. Sigmas are going to cancel. And you end up getting A epsilon naught over D. Is that that's the answer? Yeah, it is. Nice. Cool. I'll take it. That's good. That's a good start. And then what do they want us to figure out do they want us to? Oh, do they want us to calculate it, or just? Well, you have variables for this, right? Because then A is equal to L squared, and then you have D, and then you have that. Okay. Calculate the charge and the stored energy. Oh, okay. Well, if you have the capacitance, right? So then C naught times V is equal to Q. And then this is now equal to 12 volts. So wait, we can probably actually solve this. Sorry, let's solve this real quick. All right, so C naught is equal to, what's that L? 0.2 meters. So we're going to say 0.2 squared. Epsilon naught is 8.85 times, is it 10 to the minus 12? I think it is. Or, wait a minute. Yeah, no, I think I have that right. There's one where it's like times 10 to the minus 7. I think that's mu naught. I think mu naught is 4 pi times 10 to the minus 7. And then the distance is 4 times 10 to the minus 3. Sorry, and this is an epsilon naught. Sorry, this is... What am I talking about? Sorry, this is C. Your Wi-Fi keeps crashing. Oh, no, dude.
Oh, dang it.
Oh, no. Okay, cool. So then this comes out to be... Oh, look, these are actually kind of the same number, right? This is 2 times 10 to the minus 1 squared. So that becomes 2 times 10 to the minus 2, right? Or 4, sorry, 4 times 10 to the minus 2. Over 4 times 10 to the minus 3. You don't even need a calculator for this, W. And then 8.85 times 10 to the minus 12. So this is just going to become, 4 is going to cancel. And then I got just a 10 to the 1 times 10 to the minus 12. So that's going to be 8.85 times 10 to the minus 11 and farads. Farads is capacitance. Yeah. Q is carga, capacidad, and V is potential. You speak in Portuguese? Bom dia. Okay. Cool. This is 12 volts. This is 8.85 times 10 to the minus 11. Multiply that through... I need a calculator for that one. Fortunately, not anything nice. Okay. Calculator time. 8.85 e to the minus 11 times 12. And that's going to give me 1.06 times 10 to the minus 9. Oh, cool. So Q naught is 1.06 times 10 to the negative 9 joules. And then if you want stored energy, so sorry, this is part 2. This all here was part 1. Mu naught for a capacitor is equal to 1/2 CV squared. So that's going to be 144 over 2 times 8.85 times 10 to the minus 11. Sorry, and this is coulombs, not joules. Sorry, Q's and coulombs. So what is that? 72. Or actually, we can just take our original thing here and just multiply it by 6, right? Because this was times 12. We're going to times it by 72. Cool. And that gets us 6.37 times 10 to the minus 9. Joules. Cool. All right. Last part. If the plate separation were halved while the battery remains constant, while the battery remains connected, with brief justification, whether the stored energy and whether the stored charge and stored energy increase, decrease, or remain the same. Oh, very cool. Okay, so we got to think about like everything that changes. So let's remember that capacitance was inversely proportional to the distance. Okay, so let's do this. Okay, and the key thing here is if the battery remains connected, then V is constant, or the epsilon at EMF, I guess, is constant. So the potential is the potential provided by the battery is going to be the same. So yeah, all right. So capacitance goes as 1 over D. So capacitance goes as 1 over D. All right, and then charge. Let's remember that charge is proportional to capacitance times potential. But the potential is always going to be, or the EMF, I guess, sorry, the battery potential is always going to be 12 volts. So this tells me that the stored charge the stored charge should decrease then, right? Well, let's think. Okay. Oh wait. If plate separation, plate separation is halved. Sorry, we're not making it further apart. We're putting it closer to. Okay. D goes down by a factor of 2. Okay. D goes down by a factor, or let's say by a half. So C goes up. What's up? I'm from India. We study this in grade 11. Nice, dude. Yeah, this is a high school thing for sure. Also college. So C doubles, V stays constant, so Q increases. Okay. But then let's think about energy. So mu naught is equal to 1/2 CV squared. Same argument here, right? The potential of the battery is going to be the same. So I think mu also increases. And I don't think it's Q over D squared. I think it's just Q over D. Yeah. Cool. And then in justification, you can say, like, battery maintains V on capacitor. Solve the JEE advanced? No.
You done messed up, AA Ron!
We don't do JEE advanced here. This stuff is just pain. Okay, cool. All right. I hope this makes sense to you, Laplace. Cool question. I always love physics. We don't get enough of it these days.
Well done! Well done!
What's up, Alistair? Haven't seen you in a hot minute. What's going on? Still got the JBL speaker? And then Laplace. I don't know if you're in our Discord already yet or not, but every time we do one of the questions, it gets uploaded here into this channel called Homework Help, and then there's a screenshot of what we did, so you can go check it out. And if you claim this question, you get points for every question that you do. So points add up. All right. Sorry, I'm disconnected. I've been incredibly busy, and later I'll finish the last bits of our physics PBA. Is that like a personal project you're doing? Oh, this is cool. ChatGPT also used the reflection idea that Narosky did. Oh, that's cool. All right, let's see. Let's spin the wheel. See whose question we're gonna go through next.
Let's go gambling!
Lucky cat, you are lucky today, Pineapple. You had a 20% chance. Oh, is this it? This is all we have to do? This will be quick. I'm happy. ChatGPT doesn't solve our JEE. I bet it can. I bet it can these days. Ah, interesting. Yeah, Narosky, you've noticed that ChatGPT is getting better at finding the competition level tricks. It's really cool. I wonder if they're training their data sets on it. It must be, yeah. They should train it on the JEE stuff. That's what they should really do. Okay. X-intercepts are found in rational functions. Okay. By letting x equal 0 and solve for y. Well, not quite. These are what we call y-intercepts. Right? These are y-intercepts. Okay. Letting f of x equal to 0 and solve for x. Yes. I agree with that. This is impossible. No. No. And then all of the above is also not right.
Surprise, motherfucker.
Cool. Nice. Yes, so I think the answer there is B. And you got another answer for this one. Let's see. Mans said the world's second toughest exam is JEE Advanced, and I cracked all of India with a rank of 43. Nice, dude. What does that get you? I'm just curious. If you get, like, if you're the top 50 person in India who can solve the JEE exam, what does that get you? Like, do you get entrance to, like, whatever that Hyderabad Institute of Technology? Like, is it one of, like, the nice colleges you get to go to, or what? Both A and B work. Okay, for this one, let's see. Okay, to find a y-intercept. Oh, not the mains? Okay. Yes, I agree with this. This is what we talked about. Let f of x equals 0 and solve for x. No, wait,
You're
what?
not that
No.
guy, pal. Trust me.
No, we
You're not
already
that
said
guy.
this is the x-intercept. Alistair, come on. I know you're smarter than that. So this is wrong, and this is wrong. Okay, cool. Yeah, answer choice would also be A there. Nice. I agree.
Well done. Well done.
All right, we're moving and grooving. Who's gonna hit me with something hard? I'm guessing it's Mr. Silver. I know Mr. Silver. I remember Mr. Silver's question yesterday. Optics? What optics are we speaking of here? Okay. I also don't like optics, yeah.
Disqualified.
Okay. Let's spin the wheel. Choose another winner.
Let's go gambling.
It's fresh canned peaches. With the 9.7% chance. Dante, I know you're here, dude. 18%. You're close. You're getting there. Okay, here we go. 1 sec. Oh wow, this is kind of physicsy. Mr. Silver is gonna hit a hard one. We'll see, Dante. We'll see. We have to trust the Wheel of Fate. The Wheel of Fate determines all. Okay, because of your physics background. Oh, my physics background. Yeah, true. You have been hired as a safety consultant. Okay. Safety third, though. Which is planning to rebuild a section of road where the two freeways merge. The section of road will essentially be an eighth of a circle with a radius of 0.5 miles. As with many highway curves, the roads will be banked. Is tilted so that the road surface makes an angle of 4 degrees with the horizontal. Your team has been asked to calculate the maximum speed at which a standard car can safely make the turn while staying on the road. You've been asked to consider two... Man, they're going to make us do all these cases? Dude, what? A dry road, the coefficient of friction is 0.8. A wet road, on which it is 0.1. Okay, fine. Yeah. Yay, physics! Yeah, okay, cool. All right, this is not bad. This is a typical question here. All right, so... The eighth of a circle doesn't really matter. Yeah, here's what matters. Okay, so if something from, like, top down is traveling around in a circle, it's going to experience what we call centripetal acceleration. We call this, like, AC. And that's going to be equal to v squared over r, where r is the radius here, which is going to be 0.5 miles. So r equals 0.5. All right. If I then look at this from like a side view, okay, so I always say like, let's take the road here and then like, let's look at it this way and see what's happening. What we end up getting is this. So this is going to be banked. I'm going to leave everything in terms of variables just for now to make things nice. This is theta. And then, sorry, what are we? The maximum speed. Okay, we want to know the maximum speed. Okay, cool. So this is going to be the car, and it's going to be traveling like around, like this way. Again, sometimes this is kind of hard for students to see. But imagine it's like this, but then this is like the side view that we're looking at it from. Hopefully you guys can kind of like picture that. So if something's moving around in a circle this way, right? The centripetal acceleration always points inwards. So there is a centripetal acceleration pointing straight in to the right this way. I gotta remember how the angles work with this. Okay, but let's draw some forces. So you're gonna have force of gravity pulling you down. You're gonna have the normal force pulling straight up. And then if we want to know the maximum speed, the issue is that like if you go too fast, eventually you just like fly off. Because the only thing that's keeping you in is friction. If you're going too slow, actually, you would actually like fall down the ramp, but they're not asking for the minimum speed. They're asking technically for the largest speed. And so as you go faster and faster, by this condition, you need more acceleration to be pulling you in towards the center. And because F equals ma, anytime you're trying to get an acceleration, you need a force to provide for that acceleration. And the only force here that can provide for the acceleration inwards is partially the normal force, because part of this normal force does point in this direction, but also the main thing is that the frictional force is going to pull you in as well. So that's what keeps you on the road and not falling like off and having a bad time.
Surprise, motherfucker.
Okay, so we're gonna assume friction points down. Friction always points to oppose the motion that something wants to do. If something's moving very quickly, this wants to like move up that way. Okay. So I think when doing this, usually with inclined planes, you want to rotate this whole frame. But here I don't, because the acceleration I care about is in the normal coordinate plane. It's to the x direction. So I actually want to, instead of converting this into a diagonal acceleration and dealing with acceleration in two different directions, I'm going to convert these forces into directions that are just up and down right now. Okay. So, yeah, let's do sum of forces in the x direction. And the key thing here is that the sum of forces in the x direction will need to equal the mass of this thing times the centripetal acceleration. So we know, right, sum of forces is equal to ma. So the sum of the forces in the x direction needs to equal the mass times the acceleration in the x direction. And in the x direction, its acceleration is centripetal acceleration. So this is mac. But what are the sum of the forces in the x direction? Okay, well, gravity doesn't do anything in the x direction, right? Gravity points straight down. Normal force does have a component, right? So if we look at, I gotta like start making triangles and stuff now. All right, if, here, let me make this like a little bit bigger. Okay, if this angle is theta, then this angle is theta. So then this angle is also theta. Yeah, that's how I want to do it. Always remember something like that. Okay. So right here, this is theta. So then the amount of Fn that points in the x direction in this right triangle is going to be this. This is going to be fnx. I wish I had more room for it. Okay, fnx. And that's going to be the sine of this angle times fn. So we're going to say fn sine theta. What's up, Riley White? Oh, I haven't seen you in a minute. What's going on, dog? Cheat code is just right. Safely is defined differently by each person, so we can't determine an actual safe maximum speed. Additionally, let us consider a stationary truck that has been struck by a truck. The vehicle is now off the road without moving, therefore making 0 the maximum speed. Combining these yields 0 to be the maximum safe. Yeah, but then no one would get on the road, dude. What? We can't have that. Oh, man. Okay. So this is going to be Fn sine theta. Also, when I see these types of questions, I like to think about limiting cases, all right? Let's say, for instance, that my angle theta went to 0. Like, let's pretend this truck was on an unbanked curve. How much of Fn should point in the x direction? Well, none of it should. And so that makes sense with sine of theta, because as this angle, theta, goes to 0, I need the amount of normal force in the x direction to also go to 0. I know it's either sine or cosine, but this kind of like helps me reaffirm that it's sine. And then it's kind of the same thing with the force of friction in the x direction. Okay. I want to say by transversals, right? Do we remember transversals? Like two parallel lines. Let's say this is a line. This is a line, right? This angle has to equal this angle. That tells me that it's going to then be cosine of theta for the component of Fs that points in the x direction. So this so this is going to be Fsx, and then this is also theta. And so that's going to be Fs cosine theta. So here we're going to say plus Fs cosine theta. And then those are the only two forces that point in the x direction. Great. So all of that has to equal max. So mass times acceleration in the x direction. But the acceleration in the x direction is just acceleration centripetal, which is v squared over r. Beautiful. Okay. You can also check to make this make sense, because, again, consider what I call the limiting cases. If our angle here went to 0, right? If this angle dropped all the way to 0, then the amount of frictional force in the x direction should be all of the frictional force. So I need something where as the angle goes to 0, the frictional force Fs just goes to Fs. And that happens with cosine, because cosine of 0 is just 1. And so when this like drops enough angle, this just becomes 1, and now the amount of x direction forces for friction is just the whole Fs. That's how I like to think about it, because honestly, yeah, all the geometry angle stuff gets kind of messy. All right, so then we can do sum of forces in the y direction. This is not bad. And this needs to equal 0, right? This thing cannot move up and down. Have you done A transforms for bilateral non-causal systems?
Oh no.
No, I can't say I have. Z transforms, maybe Z transforms, but no, that seems kind of difficult, Riley. I'll ask my chat. Does anyone in my chat know what a Z transform of a bilateral non-causal system is? Maybe. Okay, y component. This is going to be the opposite. This one was sine. This is another thing in mechanics. Anytime the x direction is sine, the y direction is cosine, and vice versa. So this is going to be Fn cosine theta. And then we're going to have friction's now pulling down, so that's going to be minus Fs sine theta, and then minus Fg. But Fg is just mg, and that's also equal to 0. Lock in, chat. Okay. All right, so there's a lot of variables going on here, right? This kind of sucks.
Oh no.
All right, so what I want to do is I need to start redefining things in terms of other things, right? I know that in order for this thing, oh man, let's think. Can I figure out what fn's gonna be? I don't think I can. Then I know I need to cancel it somehow. Okay, but I do know I can figure out what fs is. So fs is going to be equal to mu, coefficient of friction, which we're going to say is mu s because we want to know the breaking point. So we're going to say this is the maximum friction that can be provided. And so this is going to be mu s fn, okay? That's one thing I can replace out. Then let me try to think what else we're going to have. Okay. All right, so we have fn sine theta plus mu s fn cosine theta is equal to mv squared over r. And then we also have fn cosine theta minus mu s fn sine theta. And then let me move this over. That's equal to mg. Okay. Ooh, I see something. Notice how there's an fn in all of these things, right? Look at this. fn. Let's pull fn out. So I'm gonna be really clever here. Watch this. So instead of writing fn on both of these, I'm gonna just pull it out. Let's get that. Let's pull it out of this one as well. Oh, this is beautiful, actually. This is really cool how this is gonna work. Okay. So now what I can do, so this is like factoring. If I call this like equation 1 and equation 2, if we do equation 1 divided by equation 2, it's a common trick in mechanics. This is like solving systems as equations, but like with really fun stuff. We're going to create two fractions here. So we're going to have this now. And then watch what happens. These fn's go away. No, you can divide them. You totally can. And the reason why I'm inspired to divide them is because I see that there's an fn out front on the left side of each one. So that means these are going to go away. These go away. Also here, notice how the mass is going to cancel out. See how I have an m in both things here? So now what I end up getting is... here, let's think smarter, not harder. I'm just going to copy paste. Okay, we have sine theta plus mu s cosine theta. Could you do RREF? I don't... no, not really. Could you? Maybe. You mean in order to solve... You'd have to solve... You're solving for two... No, because this is non-linear. It's non-linear. Doesn't work. Because I don't know fn. I don't know mu s. And I also don't know v. I think you need this division trick to... The division trick is cool. It cancels out the fn. Did they even tell us the mass of this thing? They did tell us the mass. It turns out you don't actually need it. Okay, and then this is equal to v squared over rg. Okay, so then here's a super dope thing. If you want to figure out what's the maximum speed, just move this over. And so we're going to get that v is equal to the square root of rg. And then it's times sine theta plus mu s cosine theta over cosine theta minus mu s sine theta. Super dope. Okay. Cool. And I recognize this. I've done questions like this on exams before. I recognize this form. It looks very similar to me. Okay. Last step, plug in some values. So we're going to have 0.8 and 0.1. So we're going to have mu s is equal to 0.8 We're gonna have mu s is equal to 0.1. And then also we knew r was equal to 0.5 miles. I don't like miles.
Disqualified.
Ew, okay. I'm gonna say r is equal to, I don't know, half a mile is like 800 meters. Say 800 meters. I can probably get the exact one. Let's see. Sorry, 804 point. It's 804.6. Okay. And then do we need anything else? Oh yeah, and then theta was equal to 4 degrees. Cool. All right, and then right, g is equal to 9.8. Let's throw it in. I'm gonna leave mu as a variable because I'm gonna show you how it changes. It's actually pretty cool. So here, we're gonna do the square root of 9.8 times 804.6 times, and then this is gonna be a fraction. So we're gonna say sine of 4 degrees minus x cosine of 4 degrees, and then divided by cosine of 4 degrees minus x sine of 4 degrees. And then let's make sure we're in degree mode. Cool. Hit enter. Well, non-real answer. Okay, because I gotta go define what x is. So let's say x is equal to 0.8. Let's say like 0.8 is equal to x. Oh, it doesn't like that either. Okay, well, let's say 0.1 is equal to x. It may be that there is no maximum speed at 0.8. Okay. Ugh, something doesn't like this. Let's see. Why are we getting a non-real answer? That doesn't make any sense. Probably someone with a calculator. Oh, okay. This needs to be plus, not minus. That's why. There we go. Okay, cool. All right. So at 0.1, you get 36.7 meters per second. And then let's do it at 0.8. Probably really high at 0.8, honestly. 85.24. Wow. This is already a lot. This is like more than 60 miles an hour. Let's see. 36.72 miles per hour. Yeah, that's 82 miles an hour. So this other one is 190. Wow. Okay. You can take this at a really high. I start to question my numbers here and think that this there may be a mistake. The process is correct. Because I don't think it should be that different. One sec. Fresh canned peaches. We'll see what chat does on it. We'll just see what it gets. But I'm pretty sure this is correct. So if I look at there's always like equations. This is a pretty well-known thing. Say maximum speed of banked curve coefficient of friction equation. Because I know I've done this one. Yeah, there you go. Okay. Yeah, RG mu plus tan theta 1 minus mu tan theta. Yeah, okay. If you divide everything by cosine, I think you get the same thing. Yeah. What's up, Mancy? Yeah, I know this equation comes up a lot. Yeah, mu's given. Mu's given. Let me just see if this works, right? Okay, if I divide this by cosine, right? Let's just make sure we got the same expression, right? Divide by cosine. This becomes 1. This becomes tangent. If I divide both sides, if I divide all this by cosine, I get 1 minus tangent. Yeah, this is correct.
Oh, yeah.
Yep, I believe that's correct. Let's see what they got from here. Yep, same answer. 82, 191. Looks about the same. Nice. We did it. Great job. Only took me 22 minutes. Right, yeah, you just divide by cosine, Zach, yeah.
Well done. Well
Very cool.
done.
This is a really good question. It comes up... I've definitely given this question as an exam on my physics classes. Yeah. Very cool. Okay. Fresh canned peaches. Hope you enjoyed that. Bum, bum, bum. If you guys haven't taken physics before, it's kind of a little preview to how it works. It's fun. I love the problem solving. Nice. Okay, cool. Let's see what we got for more questions being submitted today. This was the fun part of physics, forces, yeah. What was the not fun part? All right, let's see. It's a four-way tie. Let's go. Let's see who's gonna get it.
Let's go gambling.
It's the first Mr. Silver. Okay, Mr. Silver. Let's see what you gave. Let's see what you gave me. All right. This looks like more linear algebra, which is Norowski's favorite. A and B are equidistant from O. Given K is greater than OA, find the point P in the plane OAB such that OP equals K and PA plus PB is a minimum. Is this gonna be another like straight line thing? Is it collinearity? Given K is greater than OA, find the point P in the plane OAB. Okay. Norowski says, I don't know. Oh, wow, okay. Okay. A and B are equidistant from O. Let's just say that, okay? And we're going to put that, all right? Given K is greater than OA. Okay. Okay, and then this distance is equal to K. Given K is greater than OA. Wait. No, sorry. K. Okay, find the point P in the plane. It's in the plane OAB such that OP. Oh, okay, cool. I think something like this, right? Okay. We're going to say that this is P. So in the plane means this is all two-dimensional, right? Find the point P in the plane such, and this is OAB, cool. So yeah, A and B being equidistant from a point O, that's going to span a two-dimensional. Yes, exactly, right? Yeah. It's a 2D, it's 2D, yeah. So OP is equal to K. And they want this to be a minimum. They're talking about the length of it, I'm guessing. Play ball. Yeah, it is. It's baseball, right? Yeah, okay. PA. And then PB. Right. Okay, so if A and B are equidistant from O, yeah, they form an isosceles triangle, no? And so I got to think about, like, I feel like this is the same thing Norowski was talking about earlier, right? I just got to find some point here that minimizes the sum of the two distances, right? And that would always happen just right here, no? when they're collinear? Do we agree?
Well, K has to be greater than OA.
Okay. K has to be greater than OA. Oh, I see. It wouldn't be greater. It wouldn't be greater than OA then, would it?
No.
Well, could I just put it like
That would be
slightly?
the-
Could I just put it like slightly outside?
Maybe. What I was thinking is it would, like, if, because I don't think K has to be straight like vertical. So if you were to say like P is basically
Somewhere
just
else.
approaching either a point A or B.
What if we like put like P like over here?
Yeah, basically just as close as it could get to A, so that K is essentially just AO. Then that would minimize it.
Oh, you're saying the limit in which this like
Yeah.
basically comes to this, and then the hypotenuse of this is equal to this. Oh, okay. So the point in the plane is just at A.
I think so, but
Is that
it's,
legal?
Like,
We think,
I don't
Mr.
know.
Silver, is that legal? I guess the issue is it technically would never be bigger than it would never. Oh, it would be bigger than OA though, right?
yeah, if we consider the limit.
Uh huh. And OP is equal to K. Wait. No. Of course. Yeah. Okay, I see what you're saying. You're saying like, what if we did this, right? And in that case, OP is technically greater than OA because it's a diagonal by the triangle inequality, and then the distance from A to P goes to basically 0, and so then PA is strictly just PB.
Yeah.
Okay. I think I'm cool with that. Yeah, I feel like it, right?
I don't. Maybe I'm like, cheating it a bit, but
Mancy says, so the way to test it is AX plus del, AY plus epsilon and minimize, and then use A as your origin. Yes, you do right. Is Jeff doing it right, or am I doing it right? I'm also curious if we give this a chat. What's chat say? Let's put it on the thinking mode. I feel like ChatGPT can do a pretty good job with like 2D stuff, you know? It's not too much to visualize.
I feel like ChatGPT is gonna take like a purely geometric approach.
Sure.
Like it's gonna say like let's just take a circle in O. Because basically A and B being equidistant from from O, means that
You have a circle, right? Because O is the origin?
I'm gonna say like there's a perpendicular bisector right there, like in the middle. And there exists a circle, with the center at O. I think that's the way ChatGPT is gonna do it.
Okay.
that makes sense.
I'm thinking about this as well, but it's a bit difficult to conceptualize it.
Keep in mind, guys, this is also the person that gave us the fucking candy cane question last time.
But I guess A and B could take any point on that circle too.
Correct, right? Yeah, A and B could be
Doesn't
wherever.
matter. You can just
And
take
then-
the same point and then A
Chat's
and B are the same point, limit it to 0.
It's like really trying to go.
Brilliant.
And then, right? Because, and then as long as P is somewhere else, it would have to be like kind of outside of it, maybe? Wait. K is greater than OA. Wait. The point P would need to be outside this radius though, right?
Yeah.
P would need to be like right over here in order for K to be greater than OA. Oh, chat's really going at it, dude. Wow. Can I like view what? Yeah. What are you doing, dude? What are you doing?
Like me personally, I'm thinking of Ptolemy's theorem, but I don't think that gives you a full answer.
Pauline's theorem? Who's that?
So it's written like pterodactyl, like PP.
Oh, Ptolemy. Ptolemy.
Yeah. Because this gives you a nice inequality.
For a cyclic quadrilateral, the sum of the products of two pairs of opposite sides equals the product of the diagonals. Oh, okay.
Yeah, so basically this says that if OA, BP are concyclic or collinear, then we have equality and it's minimized. But I don't think this deals with all the cases. Because you have to consider like what happens if P is on the opposite side of the line OA to B.
Okay, you're saying like if P is over here.
Yeah. You have to consider that as well.
Well, that would definitely not minimize this, right? That'd be huge.
Yeah, but how do you know?
Because
it can be maybe.
I see. But we're also saying for any A and B, right? Is that what you're saying? And like A and B could also for any A and B. Like I could also have had this.
Yeah.
This could also be it, right?
It's not so simple. Yeah.
And then the question is like, oh, where's P?
Yeah,
so
this is what happens now.
I see. Well, the cool thing is that like P still we always know that P has to be outside of this circle because K has to be greater than OA. So it has to be like outside of it. So it's like, is it here or is it here? Shouldn't matter then, technically. Or then let's think about the limiting case if it's like right here. You're just basically getting two radii. Here.
Does ChatGPT have anything?
Oh, let's see. Okay.
Oh.
Jesus. Dude, what are you doing, chat? Oh, this was me putting it on fast mode. Let me put it on. I had it on the.
Oh.
Wait. Where? Oh! I saw something cool.
Yeah, I did as well.
Okay, here we go.
Okay.
Okay. So
Okay,
they do
sure.
it. They do it as a coordinate system. Okay. Theta equals 0 always gives a candidate. Okay.
Sure.
Oh, okay. P is the point on the circle OP equals K, lying on the internal bisector of AOB on the same side as A and B.
Yeah, okay, yeah, this is the easy case, yeah.
Yeah.
When it's on the perpendicular bisector, yeah, okay.
Okay. Equivalent coordinates with the bisectors, the x-axis. P is K0. Okay.
Yeah. Okay. Sure.
AOB with OP equals K. Wait, where was K again? Sorry. What was it? Wait, but I thought K had to be greater than OA.
Yeah, it does have to be.
Sorry, isn't sorry, when they say the bisector of AOB, right? They're talking about this, right? This thing right here?
Yeah, that's the bisector.
But I guess it has to be like slightly out.
Yeah, I think so.
Because otherwise you can't have this equal this, because that's not allowed. Okay, bisector just touching just outside the circle.
Yeah, like I do have an opinion on this.
Okay.
Like we can construct a few points.
All right, let's construct a few points. What do you want to do?
I want to take a point A prime on the ray OA.
On the ray OA, okay.
Yeah, such that OA times OA prime is K squared. And do the same thing for OB.
Okay. So you want to create some point down here, I'm guessing, right? Like here, like A prime. Because I want this times itself to equal this.
Yeah, OA times OA prime is K squared.
Oh,
So
okay.
I think
Sorry.
it should be further down.
Further this way, yeah?
No, like outside.
Oh, further outside. Okay. My bad.
No, because if K is greater than OA, and I want something multiplied by OA to be K squared, it has to be greater than OA, no?
Yes. Okay, so like K squared is greater
basically-
than OA times something greater than OA, right? Let's just say
Yeah,
OA prime,
so-
right?
Yeah, because if we fix K, let's say K is 5, right? And OA is 3. 3 is less than 5. We want 3 times something is equal to 5, for example. So A prime can be outside or inside the circle as well.
Okay. So this is A. And then we want to say that this is like A prime.
Yeah, let's say it's outside, so it's simpler.
Okay.
Yeah, let's just say K is really big.
Uh-huh.
And let's do the same thing
With
for
B?
OB.
Okay. Let's put like B prime out here, yeah?
Yep.
And then are we trying to use Ptolemy's theorem here?
Let's say A prime B prime intersects the circle.
Add like the tangent or something?
Yeah, not necessarily the tangent.
Do you want it to
So-
intersect it in two different places, or?
Yeah, in 2 different places. Because if it's tangent, then it's just on the perpendicular bisector.
Got you. Okay.
Yeah. And I don't know. Let's just say these points are, I don't know, C and D.
Okay.
Now, any of these points I think give you the positions where PA plus PB is a minimum.
Okay. Oh. I see what
My
you're saying.
construction.
Yeah. Because you mean anywhere along, wait, just these points you're saying?
Yeah.
And then also, I guess like this and this, yeah?
I think this is like if it's not on the bisector itself, like if it's not tangent, then this is the way to minimize it.
Uh-huh.
So P can either be C or P can be D.
And then what determines, sorry, where A prime and B prime are?
So we said before that A OA times OA prime is
Yeah.
equal to K squared.
Is equal to K squared.
Yeah. And the same thing for B.
Okay. And then OB prime is equal to K squared. Uh-huh. Okay, wait. Because K squared is greater than OA squared.
Yes, that's true.
Yes. And then, but we're saying OA prime is greater than OA?
In this case, it can also be smaller than OA.
It could also be smaller. Okay.
Yeah, but the most important part is that K squared is greater than OA squared. And let's just say P is any of the points C and D, and we can verify that they're minimum.
Cause says, all right. I want to know who this Mr. Silver person is who keeps, like, messing with my brain, dude. Someone said Gemini comes up with an interesting response. Can you link it to me, Cause? What's up, Bella 6000? Okay. Who is Mr. Silver? I have your IP address, Mr. Silver. Little known fact: if you upload an image to my server, I know where you are. Okay, cool. All right, I'll call this one done, just because my brain hurts.
Good job.
I appreciate the rattlers, though.
Well done. Well.
Unless Mr. Silver is using a VPN, we could figure that out.
Yeah, no, this is too complicated.
Is this like national level questions? Not as bad as yesterday's, I think, right?
I think this is past my capabilities as somebody going to nationals.
Really? And I feel like this is geometry, though. You've taken geometry, right? You have pretty good experience in geometry.
Oh yeah. I am a bit rusty though. I haven't done geometry in a while.
Okay. All right, let's see. Broken Kidney back with... Yeah, you always have fun questions, Broken Kidney, too, as well.
Yeah.
This is fourth grade
there's-
Romanian math. They're claiming it's fourth grade Romanian math.
Yeah, maybe.
All right, let's go choose winner.
Let's go gambling.
No, it's something I definitely would see if I would qualify past nationals.
If you've been past calculus, yeah.
No, past nationals. I mean.
Oh, past nationals. Oh, like international.
No. So between national and international, there's another another test they make you take, basically, because when you qualify for nationals, you are, for example, 9th grade through 12th grade students. In total are about 360.
Okay.
When you get your results back after nationals, there should be about 80 people going to the next stage.
Oh, wow.
And out of those 80 people, they take a few tests, maybe one or two, and the top 6 scorers are the team for the internationals.
Wow.
So there is a bit.
There's another step. There's another like filter.
Yeah, to make sure like you're capable of understanding like math at your level, but can you do it when the math is available to everybody, right? So there's no more formulas, there's no more anything. It's just thinking.
This is insane.
Such that somebody from the 9th grade, for example, could just completely wash somebody from the 12th grade.
Even though they haven't like technically covered what the 12th grade person has done.
Exactly.
Wow. I don't know how those people make internationals are that smart. They're just like they're super dialed in, dude. Certain people are like just, for whatever reason, just super dialed into certain activities, you know? And yeah, it seems
like take me for, if you want to make a very nice example of myself.
Yeah.
You can take me as an example of somebody who's attempting to do it, and just think, what if I was 20 times the mathematician that I am?
Wow. Maybe you already are Narosky, dude. You just haven't unlocked it yet.
Maybe.
Yeah.
It's so you haven't done calculus. You gotta.
He hasn't done
slide that
calculus
last infinity stone in. Yeah.
Yes, dude. He's just gonna get the stones and just like unlimited power, Narosky. When's your next step, Narosky? When's the next test you got? Because we know you qualified right at the regional level, I think, right?
Yeah. That was pretty simple, yeah.
What's the next step for you?
So, on the 31st, I think, I'm gonna be... No, on the 30th, actually. I'm gonna hop in a train off into some different state, different county.
Okay.
And I'm gonna take my exam on the 31st.
Wow. Well, we're gonna wish you the best of luck. And then, does that determine whether you make it to the national team, or is that to the top 360 thing you talked about?
So I am already in the top 360 overall.
Ooh, nice.
Throughout the 9th through 12th grade, I'm basically top 50th in the 11th grade currently.
Okay.
And depending on what result I get now at the national level, determines if I go on to maybe have a chance to enter the international team or not.
Wow. Imagine, dude, that'd be so cool, dude. I'm rooting for you, dude, Narosky. That'd be fucking dope.
I'm actually just hoping to get a medal. I just want a medal.
You just want a medal? I want you to get the gold medal at international, dude. Go all the way. To the end, dude. To the end, bro. Just go to the end, dude. You got it.
That's impossible.
Maybe not.
Ever since there was a student in Romania who was consistently getting like top grades and top results in competitions.
Mm-hmm.
Now he's gone off to MIT. Before him, there was a gap of maybe 30 years ever since Romania has had like a perfect score at the International Mathematical Olympiad.
Yeah.
So it's a very difficult thing to do.
But you said, isn't like the president of Romania also like a perfect score international Math Olympiad guy?
Yeah, twice. I'm still surprised that he's still choosing politics after all that.
It's crazy. Smartest politician, dude.
Yeah.
All right. Let's see. Yeah, exactly. Go Narosky. Yeah, there we go. We're all rooting for you, dude.
I'll keep you guys updated. Maybe I'll bring home the silver medal.
No.
For Mr. Silver.
Gold.
Silver.
No. Gold. Gold for Dr. Gold. Bring back the gold for Dr. Gold. Fuck silver, dude. What?
Gold is a bit difficult. I'd have to be, I think, in the top 10. Which is...
Top 10?
It sounds way easier to say. Actually do.
Dude, you're already top 50, dude. What's another 40 What's another 40 places? It's a rounding error.
It's a pretty big rounding error.
Yeah. All right, let me see if I can do this one. An ant walks along a surface. Z equals x squared minus y squared plus 4y plus 14, so that the distance from the z-axis remains constant at 2 units. Cool. Given that the ant makes 1 full revolution around the z-axis, find the highest and the lowest points of the ant. Yeah, what do you guys call this? Level curves? Level curves? This does look like a paraboloid, right? If I were to complete the square.
This is Calc 3. I forget the
Is it like Noethers or something?
I want to say it was like Lagrange multipliers or something. I really didn't pay attention a lot in calc career.
Oh no.
Me neither, too. Honestly, dog. Yeah, you're okay, dude.
I remember taking the midterm and I had to figure out Green's and Stokes theorems, and like as I'm taking this midterm, because I had done nothing on it. It was the class before the midterm, and I just didn't go to that class. But I guess I figured it out because I got the question right.
Beautiful. Beautiful. My brain these days. Distance from the z-axis remains constant. Okay. Distance from the z-axis would be the square root of x squared plus y squared, right? That's always true, yeah. Because like wherever you are here, the closest distance to the z-axis is the perpendicular line to the z-axis, which is going to be in the xy plane, per se.
Yeah.
Cool. And I need that to be always equal to 2. Right? So maybe I can...
Yeah, I believe so.
So wait, so x squared plus y squared has to equal 4. Can I use that in here to just like fuck up some shit? And then just figure out what z will be? I feel like I can.
I think so. I want something with Lagrange multipliers.
You think it's Lagrange multipliers? I forget how
I think
Lagrange
so,
multipliers work.
Yeah, let me look it up. It's been a minute since I've had to use it.
Okay, I get it because you have a constraint, I guess.
Mm-hmm.
Yeah, this is the constraint. This is whatever, and then I'm trying to maximize the constraint. Yes. Maybe I could just say like x squared is equal to 4 minus y squared. And I plug that in. I get 4 minus 2y squared plus 4y plus 14 is all equal to z. And we're just trying to maximize this, right? Yeah, I want to know.
Oh yeah, Narowski did solve that.
For Jimmy? What'd you solve for Jimmy?
Yeah,
oh, you already did. Already did this. Okay, cool. All right, let's. Jimmy, it's your lucky day. How do you know how to do this, Narowski, already, dude? What?
Well, this is just like it's very similar to like 2D stuff.
Uh-huh.
It's just adding another dimension, and it's the same rules applied.
Okay. You kind of did the same thing I said, maybe, right? Yeah, you said x squared plus y squared. Okay, I said this. I'm not totally R word thing.
Oh no.
I was able to get this. I got the x squared plus y squared is equal to 4. X squared equals 4 minus y squared. So z is equal to...
You just parameterize in terms of one or the other. I chose in terms of y because it's simpler.
Okay. So z is equal to... Okay, so then you factored this. And then, y can only go from -2 to 2. Oh, beautiful. Yes, I agree with that. Yep. Because that's the cylinder. Okay. Yeah. So then you just check... Are you just checking the endpoints, I guess?
The maximum. Yeah. And I factored it that way because we know that any square is greater or equal to 0.
Mm-hmm. Yes. Although there's a negative here though, right? That's kind of ugly, right?
Yeah, and it becomes negative. Yeah, it's strictly negative. Unless y is equal to 1.
So then I want to minimize this. Aha! Oh, that's so cool, Narowski. I see that. What were we gonna say, sorry?
I was gonna say that to maximize z, you have to minimize y. Y minus 1, sorry.
Agreed.
Basically make it 0.
Agreed. And to maximize it, you need it to be the biggest.
Yeah.
Which goes when it's minus 2. Very cool. Okay, cool. So then you have y, you have z, you can solve for x. You can solve for x. Beautiful. Okay, cool. I agree with that. That's a cool solution. I feel like I was about to get it. I was getting there. I was here. I think the part of the information I needed to remember is that y was contained on -2 to 2. I think this was the key thing I had to remember.
Yeah, and the factoring was just like additional. You could have done it way more.
Yeah. I was just going to take the derivative of that and just be like, you know, when
exactly.
0.
You could have done that as well.
But I agree, your way's more elegant. We love the elegance. The elegance is dope.
That's
I
dope.
wouldn't say it's just elegant. It's just the shorter solution. Like if I could choose between having a shorter solution or a more elegant solution, I always go for the shorter solution.
Oh, I see. So if it's ugly but it still gets there quickly, like we still prefer that.
If it gets there quickly and I have to spend less time thinking and making mistakes, and I'm all for it.
Nice. Okay, cool. All right, let's see. Dante, I really want to do your question, dude. He keeps. I'm gonna keep upvoting you to try to get you up there. He's at 42.5%. Let's see if Dante's gonna get it. Come on.
Let's go gambling.
If it's Mr. Silver again, I'm gonna kill myself. All right, sorry. Oh no, TikTok's gonna get mad at me. Oh, I said self-harm.
In game.
I don't know.
In
gaming. I'm gonna respawn. If I get this question, I'm gonna respawn. Yeah, he's gonna respawn. All right. Ugh. I might just punt on this one at this point. I'm just so tired. Okay, let 2 to the f of them be the highest power of 2. TikTok is doing too much, man. They really are. There's a lot of... Oh, man. Zach, if you're still here, me and Zach were talking about all this age verification stuff that's coming out, and I see, like, the big picture now, what's happening. They're having all these... come on, Sensation. They're having all these lawsuits where people are suing, like, Facebook and Google and whatever, saying that their platform caused them to have depression and, like, whatever, like, negatively affected their attention span and blah, blah, blah. But then they say, quote, unquote, from a young age. So then the blame becomes, you're doing this and it's harmful to children. So now the solution is we need to enforce, like, an ID, like an age check, so that we can make sure that we're not going to get sued. I don't know. It all starts to look kind of like tinfoil hatty. I'm like, oh, okay. I think these lawsuits are happening on purpose now. Got my tinfoil going.
And you're missing the bigger picture.
What's the biggest picture, Sensation? Tell me.
Well, are you familiar with Linux systems? Do you know what System D is?
System D. Yes, Zach told me about this. Apparently, System D is now integrating like an age check thing into it. Yeah.
Yeah, and people are basically saying, no, go fuck yourself.
Get out of here, dude.
It's like, that's like absolutely antithetical to the ethos of Linux in the first place.
Yeah.
Go fuck yourself.
Damn.
Which is fair. But no, the bigger picture is not lawsuits. The bigger picture is control. Because there are no lawsuits in this country. And they're pushing it in this country heavily.
The age verification, yeah, they were rolling it out, the Discord thing, but they apparently, like, they botched it and it got hacked, right? And everyone's information was just leaked.
Oh, sorry, you don't know. So they passed a law here.
Okay.
That requires age verification.
On everything?
For everything.
Oh man.
That immediately came back and bit them because people under 18 couldn't read certain news articles.
Oh.
Now you're seeing the problem.
Yeah. Yeah, no, I see it. Yeah. Yeah,
It's
you need to be informed.
beyond censorship.
Yeah,
It's like,
I
oh,
know.
you're underage, you can't look at porn. Well, they're going to anyway, but point is,
Yeah, they'll
they
find
couldn't
a
even
way.
read news articles.
You can't
And
even
it's
like
you know,
learn about
if you're
calculus.
If you're 17 and you can't read about a particular news article because somebody got shot, it's like it's nonsense.
Yeah, it's only recently that it started like crossing my radar, and yeah, Zach was bringing it up. I had a meeting with him the other day or something, and he was bringing up the whole System D thing and how you can use like a different, like I think it's called a daemon, a different thing other than System D, but it's just a huge pain in the ass.
Demon, and
Demon. Yeah.
I don't use System D. I'm still relying on the old one. Shit.
Dude, I don't know what System D is. I just have whatever the Ubuntu thing is, but like I refuse to. Yeah, I'm not verifying my age. Actually, I think I accidentally did do this on Roblox. And I can't talk to any of the students on Roblox because I'm too old for them. Apparently, I'm like, what? Like, we talk here on Discord. What are you talking about?
Like I said, it's all just a function of control.
Yeah, it's all control, dude. You know, you would love it, dude, because this was me debating the flat earther guy. Did I tell you the sensation? I went on a YouTube thing to debate a guy who believes the Earth is flat.
I was aware of it.
Yeah, and he talks about how it's all control. He says like forcing us to believe the world is round is a control mechanism. I was like, oh wow. So maybe there's some truth to it. I don't know. I don't think the world is flat, but.
Well, no, because forcing somebody to believe something that's not true, you can just prove that it's true or not. So it's.
Yeah, I don't know. It's like too many double negatives, I guess.
Americans in a nutshell. I didn't do nothing. It's like, so you did do something.
I didn't do anything, so you did do something. We're coming after you.
I didn't do nothing. What did you do? I just said I didn't do anything, but you said you did do nothing. So.
Tell that to TikTok, dude. Like constantly, like censoring. Oh, we did not get censored from me saying I was gonna respawn if I got this question. I haven't
respawn. Commit suicide.
No, we can't say that word. Can't say that word. Sensation.
Oh no.
We can't say it. We can't say that word.
There's plenty of. Oh well, don't even get me started on what's that? A certain event that happened in Chinese history that you're not allowed to mention. It involves. A tank
interesting.
And a
Yeah, the one with the the tank and the person in the protest. Yeah, or you can't. You can't refer to a specific Christopher Robin's favorite pet person. TV
right,
show.
yeah.
Tigger's friend. Yeah.
Oh bother.
Oh bother. All right. One sec. I'm gonna just punt on this question because I don't know if I can do this one. And also, we did another Mr. Silver question, so I'm gonna put it in our server.
This one actually seems way simpler.
Oh, is it? Okay. All right, then maybe let's do it. All right, let's try to do it. Because I want to make sure I get Dante's question.
Yeah, if n is odd, then f is 0.
Okay, let 2 to the f of n be the highest power of 2 dividing n. Okay, so we're saying like n modulus this is equal to 0. Is that what we say?
Yeah, that's the fancy way of writing it. Yeah.
Okay. All right. Let g of n equal f1 plus f2 ... f of n. Prove that the summation of e to the negative g of n converges. Okay. Converges. Wait, g of n's a series,
Yeah,
no?
What? Sorry.
Is g of n a series, Narowski? Because it says g of n is equal to f1 plus...
It's just the sum. It's just defined as the sum of all f's.
Okay. So
up to n.
So when I do that here, that's the same thing as if I were to pull them down. Would that be the summation? Sorry, I'm just getting confused here. Is this sum also summing over this stuff as well?
Yeah, it's specifically summing over n. Yeah.
Got you. Okay. So this is the same thing as e to the f1 or e to the minus f1 plus e to the minus f2, right?
Oh no,
Or-
no,
No. Oh dear. No.
no. It's
oh no.
Oh no.
It's e to the minus f1 plus e to the minus f1 minus f2 plus.
Oh, okay. E to the minus f1 plus e to the minus f1 plus f2. Is that what you're saying? Sorry.
Minus yeah,
Like this,
plus f2.
right? Got you.
Yeah.
And then it's
And
plus.
so on.
Okay. E to the minus. I'm just gonna write this the next one just so I'm happy. Okay. Okay. What's up, Zombie?
Yeah, I think this is just a case of if n is even or if n is odd.
Okay.
Because n is a natural number. It's an integer greater than 0.
Uh-huh.
So if it's odd, then f of n is 0.
If it's odd, f of n is 0.
Because if it's odd, the highest power of 2 dividing an odd number is 1.
Oh, right. Oh, okay. I think I see this. If n
so if n is odd, then f of n is 0.
Okay. Yeah, no, I see. Okay, so yeah, if n is odd, it's only divisible by 2 to the 0, which is equal to 1. Okay.
Yeah.
And
so basically that forces f of n to be 0 for all n.
okay. So f of n equals
that's pretty
0
simple.
for all n.
And of course, then g is 0 and it converges.
Oh, okay. And then right, summation e to the minus g of n is just equal to 1, right?
Yeah.
Oh, cool.
My man.
Oh,
But what if
think
n is
it's,
even though?
If it's equal to n because it's e to the 0 plus e to the 0
Oh,
plus e to the 0.
right. Okay, you're right. E to the 0 plus e to the 0, so it's just equal. Yeah, plus dot. So it's just equal to n. Okay.
So it converges, yeah. Okay.
What about if n is even?
So if it's even, then f of n is greater or equal to 1. That's all I can come up with. Oh,
F
and
of-
yeah, it's greater or equal to 1. And because it's greater or equal to 1, we have that g of n plus 2 is greater or equal to g of n plus 1.
Yes.
Not of n plus 1, of n plus 1.
Oh, okay. Sorry. G of n plus 1, like that.
Do you see how that happens? Because g of n plus 2 is just the sum of f.
Okay, so sorry. So g of n plus
It's the
2
sum of all x. Yeah.
is f of n plus f of n plus 1 plus f of n plus 2, right?
Yeah, and all the ones before it. Yeah.
And all the ones before it. Then this would be all the ones before it plus f of n, right? And then f of n has to be greater than or equal to 1. Oh, I see.
Yeah.
So why do I need n plus 2 as well?
Oh, it's just
Like,
for
could
the
I just
next
say
step.
okay, it's for the next. Okay, that's fine.
Yeah, no, it's just for the next step to make sense. Because if you take just n plus 1, it doesn't.
Oh,
entirely
also,
make sense.
sorry. N has to be even. Sorry, you're right. Sorry. Yeah.
And n is even as well. Yeah.
And n is even. Okay, that's why. Got you. Thank you, Jeff. Okay. All right. What's the next?
No,
step?
because it makes a lot more sense when you consider that now the series is gonna be dominated by something
Uh-huh.
that converges. So the sum of basically the sum that we're trying to prove converges is going to be dominated by just
The
1
highest.
plus. Yeah.
The highest term, though, right?
Yeah, which is just going to be 1 plus 1 over e plus 1 over e plus 1 over e squared plus 1 over e squared.
Uh-huh. And then
so
this
on.
is a P series, right?
It is, yeah. And it's less than something. It converges anyway.
Yeah, which is a P series, but 1 over E is less than 1, so it converges.
Yeah.
Yeah.
I think it converges to like 2 over something. I don't know.
Yeah, it's probably like
2
1
over
over 1
minus-
1 over 1 minus R or some shit, right?
Yeah, it's 2 over 1 minus 1 over e.
Yes. I think it is that too. Right, yeah,
Yeah.
because the first term is, yeah.
Yeah.
Oh, because it's doubled. Okay, oh, I see.
Yeah, it's just itself twice, yeah.
That's the bound, not the answer. I think we just had to show that it converges. We just had to prove that it converges. We don't have to get the actual answer.
Yeah, it doesn't matter because all you have to show is that it converges. So if you bound it by something that's convergent, it has to be less than a real number, which is basically proving that it converges.
Yeah.
And we know it has a limit because it's a sum of e, of an exponential anyway. And the sum of exponentials cannot be like the sum of a function that is elementary, and in this case exponentiation, cannot not exist. Right? There's nothing stopping it from existing.
Yeah.
So it converges.
Beautiful. Okay, that wasn't so bad.
Yeah, this was simple.
This was simple. Simple. I want to find out who Mr. Silver is. I have a hinting suspicion that Mr. Silver is Narosky, causing me to like deal with my alter ego to make myself a better math person.
I don't know. I'm not sure.
Oh no.
He did say he was going to bring back the silver from the competition, not gold. So
Can't be him, dude.
Obviously, don't go and do that.
Don't do that, dude. You gotta bring back the gold. Okay, let's spin. Dante, my poor boy Dante, who submitted how many? You submitted 2 hours ago.
2
Bless you,
hours
Dante.
ago.
Bless you, Dante, for staying with it. Bless you, Dante. I really hope the best for you here. I really do. I really do. Let's see.
Let's go gambling!
If Dante doesn't get the sound, I'm gonna be disappointed.
It is you, Dante. Congrats. I don't have to respawn myself. Oh, man.
Aw, dang it.
This one's not bad.
Is it not bad?
This
Okay.
isn't
sorry.
bad, man.
No,
this
this is
one's
bad.
pretty easy.
Okay. All right, let's do it. All right. Go away, Mr. Bean. What are you doing here? Okay. All right. Differential equations show that if P satisfies the logistic equation, then d squared p dt squared is equal to k squared p... Okay. What's the logistic equation? Why are the certain slices bigger than the others? Because they have a greater percent chance. It's chance. You could maybe ask me why does it always fall in the middle of the slice? That's because it just determines who the winner is, and then that's the animation it makes. Yeah. Okay. I see. So they just want me to take another derivative of this? Is that all they want me to do? It's kind of cool. I can do that.
Yeah, I think so. I was hoping that it was like solved it. But I guess that works too.
Yeah, I guess this works too, right? ddt of dp dt. Well, that's equal to d squared p dt squared. Okay, cool. And then we're gonna do ddt of kp 1 minus p over l. This is going to be a product rule because I got two things with p in them. Or I guess I could multiply it. No, I don't think I want to multiply it through. Maybe? No, I think I want to. Well, let's see. The final answer is factored. P and L are constants. No, they're not. P is the population, no? At time t. I think, oh, sorry, you're right, Jeff. Sorry, P of t is a function, L is the constant. Correct, okay. Yes, okay. All right, so let's do derivative of the first is just, what is it? It's just, this is where you have to do like partial derivatives, I guess, right? So it's just k dp dt, right?
There would be no partials in there.
No partials, yeah, sorry. Just full derivatives.
Because it's all just constants.
Yeah, you're right. Yeah, I don't have to worry about k. Okay. And then this is plus kp, and then this is going to be minus 1 over L dp dt. I think I did that correctly, right? And then this is equal to d squared p dt squared. Oh, I think I remember where this comes from. Blah, blah, blah. Man, this is so ugly. Because dp dt is the same as this. All right, screw it. Let's do it. Maybe something nice comes out. Okay. So that's k. And then dp is equal to this. So that's going to be kp 1 minus p over L. Oh, times 1 minus p over L. Love that. Okay, cool. So that's going to be 1 minus p over L squared. And then plus kp negative 1, or here, we'll say minus kp over L. And then this is going to be the same thing here. kp. Yeah. Okay. What am I trying to factor out? I want to do 1 minus pk, 1 minus 2p over k. I don't feel like I have that. Where's that 2 coming from? Okay. I do. Factor. Okay, let's do it. All right, so let's factor this because I see k squared p. Okay, so I have k squared p, and then that's k. No, sorry, k squared p times this. Okay. Minus k squared p, and then it's p over L. Right. 1 minus p over L. Thank you, Sensation. I do need to hydrate. Okay, and then y'all are saying 1 minus p over L can come out as a factor. Sure. So that's 1 minus p over L. And then we're left with k squared p. And then this is 1 minus p over L. Oh, minus p over L. Ah ha 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 ha. I see. Well, this is factoring madness, dude. What? Okay. Actually, let me put this as a separate color. 1 minus p over L minus p over L. Wow, that's so cool, actually. Okay. Okay, cool. So then I get k squared p, 1 minus p over L, 1 minus 2p over L is equal to d squared p dt squared. Wow. That's super cool. Except I put it over k. Oh, I think they use... All right. Okay, let L equal big K. K-shaped economy. Show that a population grows fastest when it reaches half its carrying capacity. Well, okay, it grows fastest when the derivative of dp is equal to 0. So when the second derivative is equal to 0. Yeah, exactly. Right. So the rate of growth. The wording here is kind of weird. This is dp dt, but the fastest rate of growth, not the maximum growth, not the maximum like population. That's when the derivative of dp dt is equal to 0. And I guess also the third derivative would be negative. Okay, so this is equal to 0 when, okay, p equals 0, but trivial. We don't really care about p equals 0. Or p equals L, or p equals L over 2. Okay. So then, this one is trivial. These are the questions, right? Which one? Do I want to take another derivative?
Oh, dang it.
I don't think you have. I think
I
just kind of off the spec, because it's representing
I can just
the
plug it
growth
into
of the
here.
population.
Well,
you could just say like based off inspection, once it gets to its carrying capacity, it has to go down in population at that point.
Yeah. Or
But if
okay.
it's halfway in its carrying capacity, it can keep going up.
Exactly. But it could be oh, you're right. There is no more growth. Oh, you're so right. Yeah. Duh. Yeah. Once you're at the limit, you can't grow. Okay. That's one argument. We could say like, but at carrying capacity, there's no more growth. No more. Yeah. There's no more growth. The other way, yeah, Zach's right, is that you could evaluate it. We could evaluate what it is, right? Or evaluate. And what we'll notice here is that at p equals L, dp dt is equal to 0. So this is probably a minimum then, no? That's the minimum amount of growth. And at p is equal to L over 2, dp dt is equal to... what happens here, actually, sorry. L over 2, 1 minus P over L over 2. Wait, no, wait. No. L over 2L. I see, yeah. Yes. This is calculus, Patrick, yeah. Well, it's actually kind of like differential equations, maybe, I think, technically. So this goes away.
I think this is like a Calc AB problem. I feel like.
Yeah, it could be.
Because
So
they have a unit in differential equations, but they don't go like far into it. They just talk about like this equation and not much else.
You guys mashing F5. Yeah, I agree. Okay, cool. Dante, thank you for waiting. Does this make sense to you, Dante? Appreciate you chilling here for 2 hours. We got Master Chief coming out. Okay, cool. Dante. You did it, Dante. Because I know Dante was mashing the upvote button too. I saw you, Dante. Dante, I'm going to put the solution to your thing here. If you want to join our Discord, The link for that is right here. Join Discord. And then you'll see your question here. If you want to like just react to it, I can make sure you get credit for asking the question. Okay, I'm about out of time. Let me see what else is on the... Let me see what we got. That's one? Okay. What did Alcvix get me? Oh, this is physics. This isn't too bad. Alcvix. A long straight wire carries a current I out of the page, which is uniformly distributed over the cross-section of the wire. The value of B.dl, the line integral of the magnetic field B around the wedge-shaped path, equals which of the following? Oh, okay. I can do this one real quick, and then I'll let the thing just spin. Just so. Let me just make sure I help this one out because I can do this one. Yeah, the key thing in this is that B.dl. Sorry, let me go. Sorry, B.dl, integral B.dl is equal to mu naught I enclosed. And so they say the current is coming out of the page this way, and it's over this area. And so this is the path, right? And so you want to figure out what's the amount of current being enclosed here. Well, that's going to equal to the proportion of the area that is enclosed. And if this is theta, right? Area enclosed. What's up, Yippee? That's equal to theta over 2 pi. That's like the percentage of area enclosed. I think. Yeah, right? Yeah. Because if it was 2 pi, then you enclose all the area. If it's pi, you only enclose half of it. Beautiful. Okay, cool. So, B.dl is equal to mu naught I enclosed. And then, here we go. And they say, okay, there's a uniform current I. Oh, okay, so it's just this. It's just mu naught theta over 2 pi I. Right? This is the percentage of the area. This is the total current in the area, or the current in the total area. So it should just be this. Mu naught I theta over 2 pi. I think it's just that one. Yeah. Just say. Cool. You don't actually need the area. The reason why you don't need it, Zach, is we say that the current I is uniformly distributed. So the total I is uniformly... There is like a current density, technically, but I don't need to worry about it. Otherwise, I would need the area times the current density. But I know that the whole area contains the whole I. So I just need the percentage. Yeah. That's where that comes from. Zach, we're going to teach you E&M one of these days. Yeah. And you're going to help me out with real analysis. I got the book, by the way. I got the book. It came in. Alright, let's mark that as done. Oh, I marked the wrong one done. Damn it. Or whatever. Let's mark them both done. Okay. This is AU2. Vix. How's the book? I haven't opened it yet. I literally it was sitting on my doorstep after I got back from Japan, and I was like, ooh, I should take a look at this. One of these days I'm gonna DE are missing theta dependence and don't account for the wedge only covering part of the full 2 pi. Yes, I agree. I agree there, Bella. Ah, I see Terence Tao. Daka new SD Terence Tao new Frechi. I'm gonna speak Romanian one of these times. Okay, cool. All right, I'm out of time. Let's close out the stream. Thank you everyone for coming on the Actual Education Office Hours today. Really appreciate all you guys. I learned a lot. Appreciate your presence. Your presence is a present. We didn't get censored by TikTok today.
That's dope.
Sensation's like, there's still time. I could still say some things about juice boxes. Oh, man. Okay, great. Appreciate everyone. Yes, thank you, GG's. Yeah, you guys are awesome. I always learn stuff. Love it. Our next stream. So if you go here to the website actualofficehours.com, go click on the streaming schedule. We're gonna have a chess tournament on Saturday. That'll be on our actual gaming stream technically. So make sure to join the Discord if you want to come play chess with us. We're giving out like cash prizes, so come play chess with us. It's fun. Otherwise, go check out Penn Center. Let me give a shout out to Penn Center, who will be on tomorrow morning doing some fun stuff. Hash functions. That sounds cool. That's like cryptography. And then Eric is going to be doing get good graphs. You sent one last question. All right, let me look at it real quick. If I can do it real quick, maybe. If not, I do have to go. Dude, this is the curvature of the Earth? Oh no. Yippee. Yo, are you Yippee. Is this Nathan, dude? Nathan, are you sending this to me, dude? This is literally what I was talking about with my flat Earth debate on Tuesday. I hate optics. I hate this type of stuff. I feel like it's all wrong.
Oh no.
No, I do have to go. But this is cool. We could get into this later. This is great for it. I will save this into our Discord. If you come by on Sunday stream earlier, I'll have time to do it. But I might come, but I've barely played chess before. Totally cool. Some people like really haven't played any chess at all. The only way you learn to get better at chess is by playing chess. So come on by. And you always have a chance to win the prize. You get 1 point if you play, 2 points if you stalemate, 3 points if you win. And then the amount of points you get determines how many slices on the pie you have for the drawing. So come on by for that. It'll be fun. Yippee! Make sure go join our Discord, dog. Here, if you click here, so the website you went to go submit, go click join our Discord. Any questions we don't get to today get put into the queue, like into our forum here. And they may get solved later by somebody else, or they may get solved by, we have like a bot that'll go through and like solve them. But yeah, okay. That's all I have to say for you guys. And then our next like tutoring stream will be on Sunday, so we'll go do that. All right, so that being said, let's go raid someone on Twitch. Who are we gonna go say hi to? Fizzbuzz. Oh, I like Fizzbuzz. Silly guitar practice. That could be fun. Anybody else doing any like science stuff? Science is playing a video game. It looks like everyone's just chilling because it's Thursday. All right, go say hi to Fizzbuzz. Fizzbuzz is a cool person. I met them at TwitchCon as well. IRL. We got to get Zach to TwitchCon. Start the fundraiser. But yeah, come on. Go say hi to Fizzbuzz. They're a great other physics person who also streams physics. I think they're just streaming guitar stuff, but you can go say hi to them. All right. Enjoy the rest of your Thursday. We will see you Saturday for chess. Otherwise, we'll see you Sunday for office hours. Enjoy the weekend. Peace.
Actual education, Dr. Gold. What's up? Thank you for the